Welcome to the Passive House Show, where we talk about all things Passive House and why the Passive House concept is the answer for the future of home building. In this first episode, we'll introduce you to the concept of Passive House and explore what makes it such an exciting and innovative approach to building homes that are comfortable, healthy, and energy efficient. My name is Mick, and I'm joined by the real host here, Paul Kealey, CEO of EcoBuilt Passive Homes. You doing good?
Doing great. Ready to talk passive.
There
Absolutely.
we go. This is the fourth introduction we've done without screwing up. All right. Well, to get right into it, this is going to be the introductory episode to those of you who don't know what the Passive House concept is. So, Paul, question number one: what is Passive House, and how is it different from other approaches to building sustainable homes?
Your passive home is ultimately the epitome of a low energy house. So it's a house that, compared to all the other construction models out there, saves a ridiculous amount of energy. So it's important for that understanding, people to understand that it is an actual construction model. So there's energy criteria that have to be met in order for the home to be considered passive. And a lot of building science is ultimately part of the equation. But to throw out some other construction models that people might be familiar with. So a building code is ultimately a construction model, but it's the world's least energy efficient standard. Building a home to the basic requirements that. Ultimately in today's world, costing people a fortune to heat and cool spaces, to be comfortable, So what's happening in those code built homes, people are keeping the temperature set lower and higher in the summertime, and ultimately living in an uncomfortable state. That's not very healthy. But Energy Star, a lot of people are familiar with, which is not much better than code, but it is a 10% improvement. R2000 for the Canadian model, which would be the best Canadian energy efficiency model, ultimately has twice the air tightness and twice the level of insulation compared to a code-built home. The LEED system, a lot of people are familiar with. So LEED standing for Leadership in Environmental and Energy Design. Okay, so LEED homes are good in the sense that it's a great overall sustainability concept. So it's a rating system, a construction model that focuses on energy savings, but also green materials. So healthy, theoretically healthier house for the person living inside the home, and healthier home for the world that we live in. Which is ultimately the way our passive system is designed. We like to follow the LEED system for all those environmental benefits and ultimately health benefits for our world and us living in the house. So it's a great standard. And then, besides those, moving into net zero. So net zero is becoming more dominant language in the construction world. And everyone's talking about, many governments around the world, Canada, the US, and over a couple hundred countries have committed to mandated legislation with respect to net zero building. So net zero, this is why we say, best protect your investment. The net zero building standard will become the official building code, potentially by 2030, if not by 2040, 2050. We build our homes to last a long time, so building a passive house in order to protect your investment, to have a house that is ultimately designed for these future code standards, near future code standards, ultimately the only type of house to build to best protect your investment. So passive home, compared to ultimately all these other construction models, rating systems, I always remind people that, great to consider everything that's out there. But when it comes down to it, the passive home is the only home that truly protects your investment from a construction model perspective, because it's the only system where building science is part of the certification process, part of the approval process. So in order for our company to have our own certified system, certified to the International Passive House Standard, we have to prove that the home is not only airtight, but vapor tight, watertight, that has a specific thermal envelope to use under a specific energy threshold. But most importantly, that the wall system, the foundation systems, the roof systems are also open permeable. There's a lot of moisture that ends up in these wall cavities, roof cavities, immediately after construction. So that moisture has to be allowed to dissipate to the outside, and ultimately, this is what dictates how long a house is going to last.
The last thing you want, people, is a moist house.
Moisture, exactly. Moisture leads to mold. It leads to mildew. It leads to damage.
It's real bad. Yeah. It's real bad. That's fantastic. Would you say? I mean, like, you did the research and you went in. That's why you went into building passive houses, right? It's the most sustainable across the board for many, many reasons. The second question I got for you is, how do passive houses work, and what are some of the key design features that make them so energy efficient?
There's a number of them. Great questions, but how does passive house separate itself from the code house or these other standards? Ultimately, when I think about it, there's 5 parts, 5 main components. So it is, what I refer to as a holistic concept. It's a sum of all parts. And the main parts are the air tightness. Okay, so air tightness, if we had to signal out one particular ingredient of what makes any house more efficient compared to its alternative or different ways of building it, it would be related to the air tightness. So a passive home needs to reach an air tightness standard of 0.6 ACH. ACH meaning air changes per hour. How does this compare to a building built to code? Most homes built to code, unfortunately, aren't required to be tested. Depends how well the home is built, but ultimately could experience anywhere between a 3 to 10 air changes per hour air leakage rate. So,
how many air changes do you think a tent would have?
A tent would
almost the same as a code-built house.
Yeah, pretty much. It keeps the wind out, right? But when you're inside for more than a half hour in a cold climate, you end up freezing. So
do air tightness tests happen in conventional houses?
They don't. Code does stipulate that any house built to code needs to have a maximum 3 air changes per hour. But this is the problem with the building code. There's simply no testing requirement.
That's crazy that they wouldn't do that for houses in Canada, of all places.
Absolutely, yeah. Yeah, exactly. Because, you can have, when we look at code with respect to insulation level, R22 is most codes in North America insulation level called out in the wall. R32 called out or 36 carried out in the roof system. But if the home is full of air leakages, the insulation doesn't...
That R value is worth nothing.
Doesn't work at all. Which is ultimately the second component that would separate a passive home compared to these other houses. So passive home wall assemblies for at least our climate are equivalent to an R75. The roof system is equivalent to an R110. So, ultimately there's 3.5 times the insulation that goes into a passive building than a code building. And coupled with the air tightness, for these 2 parts of a passive home, it really, the home is built like a thermos. It's airtight, vapor tight, super insulated, thermal bridge-free envelope. And, the home is draft-free, stable environment. It's why we only need one heat source in the living room. And it can keep the entire house very comfortable and easily heated with an air source heat pump. So, like what I said, their thermal bridge-free design is ultimately the third component that separates a passive home different from most other homes. So, thermal bridge free design, meaning that there's no material that is both connected to the inside finish of the house and the outside finish. So compared to your standard, you can still build to the really basic building code. You can still build a house using a 6-inch framed wall assembly. So a 2x6 that's in these wall assemblies, these basic code assemblies, are connected to the drywall in the interior, and they're connected to the siding on the exterior. So it's ultimately considered as a pathway for heat. That frame material will absorb a ton of heat and radiate it directly to the outside. And that's why these homes are so energy intensive. So passive home, eliminates all requirements. It's for thermal bridge. The entire design of the building has to be thermal bridge free. Foundation systems, wall systems, windows and doors even have a thermal break right in the middle. So there's ultimately an internal frame, external frame for the windows, roof systems as well. And, most important strategic part to the design as a result is the connection details. So where the wall connects with the foundation, where the wall connects with the roof system are strategic details. And, those three components, the air tightness, the insulation, and thermal bridge-free design ultimately make up the general building envelope. Windows and doors are also extremely important. So windows and doors are, I compare every week, you got to compare passive to something to make sense of it, right? And comparing the windows to a conventional window, conventional windows, everyone's heard of low E coatings that are ultimately standard on any window you can buy. Even windows that you put into your garage have a low E coating. So low E stands for low emissivity. It means that the windows are designed to block outside sun and to instead prevent the heat from inside the home in the wintertime from radiating outside towards the glass. When it comes down to it, a window is the weak point of any building. Even a passive house window rated at approximately an R10 to R12 is the weak point of the envelope from an energy consumption perspective. But the difference between a passive and conventional window is passive windows are also designed to let the sun in. So taking advantage of that low angle winter sun, windows that are designed to let the sun into the building, also designed to prevent the heat from inside the home radiating out like a conventional window. But what's interesting about the solar gain capability of the glass is when the windows are facing due south. So if your ideal passive house to take advantage of this faces due south, has the living rooms, living spaces facing south. And done this way, even in extreme northern climates like we are in right here, 3 times the amount of energy comes through the glass then leaves the glass.
That's amazing.
So ultra net gain, net positive window. And this is ultimately the biggest part of the reason or example of how little energy is required to maintain that comfortable indoor environment. Again, it's like adding a refrigerator to the house. It's that simple.
It's that energy efficient. That's fantastic. All right. What are the benefits of living in a passive house, both for homeowners and the environment?
The benefits of living in a passive home. So, for house and environment, I think of a passive home, as ultimately a type of house that is at the intersection of sustainable living. So the intersection of sustainable living for the person that's built the home and living inside the home and our world. It's ultimately a house that focuses on the well-being of us as people and the well-being of our world. And it does that a number of ways. So, with respect to carbon, so climate change is a result of excess carbon in the atmosphere. So it it removes carbon from the equation, being entirely electrically operated. So it's good for the person living in the house because we don't have to worry, like from a health perspective. The home is being heated by gas or propane. There's always that risk of carbon monoxide on the inside of the home, and there probably is a trace of it inside every home. So carbon-free, nothing to worry about. Carbon-free for our environment. Ultimately, if the world is a carbon-free world, then climate change will start to reverse itself, right? It's a known fact that 30% of building emissions, even today, are related to carbon dioxide emissions. So if we simply build carbon-free, build passive, we solve climate change 30% instantly. Technologies are here, passive houses here. So, from a carbon-free perspective, use it. Energy, low energy. So, low energy qualities of a passive home equate to massive savings for the person living in the house. So one single utility.
That's a good benefit.
Huge benefit, and just being, a lot of people don't realize, but just being connected to a utility costs a significant amount every year. Being connected to a gas service or a propane service, usually the cost just to be connected could be anywhere from $500 to $1,000 a year.
For those of you who don't know, passive houses don't need a furnace. Even here in Canada, where it can get down to, here in Ottawa, it can get down to like minus 30.
Yeah, minus 35, like even we've seen.
Yeah, and you still don't need a furnace, which is just fantastic. You completely eliminate the need for gas in your house.
Mm-hmm. Absolutely. Good point. So like the air source heat pumps we're talking about are able to, really cool machine, able to extract enough heat energy out of the air at minus 35 degrees Celsius to comfortably heat a passive home.
That's fantastic.
It's pretty wild, and on that note, to get a bit technical, because I'm sure there's some technical people out there that want to hear all about the numbers. Ultimately, from an energy perspective, a passive home only requires about 10,000 BTU of energy on the coldest day of the winter in most areas in Canada. Compared to your typical code built or even Energy Star home, that BTU requirement can be anywhere from 60,000 to 100,000 BTU.
Wow. That's staggering. That's crazy. It's like living in a tent if you got a conventional built home.
It really is the difference. Yeah.
That's
the
crazy.
Epitome of energy savings.
Gosh. All right. Next question. How are passive houses being adopted around the world, and what are some of the challenges that builders and homeowners face when trying to create these homes?
So, the first challenge I'd say from a builder perspective is, in general, it's still a newer building, so it's a type of home due to the thicker wall, the thicker roof systems are ultimately don't follow the typical construction practices that most building codes are designed for. So having an engineer that is able to stamp the building, put an engineer stamp on the plans, is a prerequisite. And having the engineer approval really solves all of the builder problems, because thinking about that originally, my thought is always the building department, the building inspector. Is there going to be any problems with the inspector from an inspection standpoint? Because like any other home, you want the house to be built and occupied as quick as possible, so that it saves money for the whole overall construction process. So standard part of our way of doing things is providing engineered stamp drawings. Most homes, say even code build homes, have some type of engineered lumber in the system. Even if the floor system contains a number of engineered beams, ultimately any engineered construction material has to be approved by an engineer. So we simply, instead of let's say we were a conventional system and sent our design to an engineer to approve the floor system and the roof system. We're simply having an engineer approve the entire structure. And it has great additional benefit because, now an engineer is confirming the snow loads, the wind loads, the rain loads. So loading for everything on the building. And, this we can tie resiliency into this conversation at this point too, because just like we said before, passive homes from an insulation perspective contain about 3.5 times the insulation compared to a code-built home. Due to the way a passive building is constructed, the thicker wall assemblies allow opportunity for continuous vapor barriers, or which are actually requirements. So continuous vapor barrier requirement, air barrier requirement, water barrier requirement, different other opportunities to bring in more structural elements into the structure. And with with our system in particular, it's a type of house that is ultimately built 3 times stronger than your code built home.
Absolutely.
We got tornadoes happening in Ottawa, in an area where tornadoes are not supposed to happen. So building the home stronger, resilient, should be a standard code change coming in the future as well. And passive home has a lot of those great protections. So, eliminate all problems with respect to builders, building departments with this engineer stamp. And there's so many other benefits that come along with it as well.
I guess part of the question here is how are passive houses being adopted around the world? We should mention that passive house design was created in Germany, right? Back in the 1980s?
Created in Germany, actually. The research started in the 90s, but it didn't become a standard until 2006.
Oh, the standard started then. Okay, right.
Yeah, so just about 17 years ago.
Yeah, but the technology has been around for a while, right?
It has, yeah. The technology has been around for the while. Like even our 2000 homes contain some passive ideas. And, passive, from an idea perspective, is, simply a house that can passively heat itself, passively cool itself through a good portion of the year in any climate zone. With respect to Germany and the development of passive and the original ideas in that area of Europe, ultimately the ideal passive home being created in this environment is a type of house that doesn't require any heating or any cooling. So, of course, this in this situation, that house can only really be in a particular climate zone. If the area is very temperate, like where we are located in Canada, so freezing cold winters, hot summers, so you got a lot of temperature fluctuation. Germany, the temperature might not go below -5 degrees Celsius or above plus 25 degrees Celsius. 25 degrees Celsius is the temperature criterion that passive house uses for summer comfort. And room temperature, 22 degrees, would be the comfort criterion for winter comfort. It's so different every area, but your ideal passive home is in that situation where you don't need any heating and cooling. And apart from that, even where we're located in Canada, the heating season is reduced from, most homes in Canada are heated 6 to 7 months a year, whether it's full-time or intermittent. And the passive building in the same area only requires a heating system to operate for approximately 3 months, so less than 50% of the time. Cooling systems are only required to be used whenever what I refer to as heat wave conditions. So if the nights are above 22, 23 degrees, so if ultimately...
That's not comfortable.
Not comfortable, yeah. It's going to, the heat's going to mitigate itself inside the home at some point. But in this area, we don't get much of that. We might have a couple 2 to 3 week periods of summer, so air conditioning required for that 2 to 3 week period. But that's it. That's only in southern climates, so southern U.S., Florida, Georgia, Arizona, the Carolinas. The difference would the savings in air conditioning would ultimately be the equivalent to the Canadian savings in heating. So instead of saving 90% of heat energy, it's going to save 90% of cooling energies in the southern climates.
Absolutely, which also is the case up here as well. Yeah.
Absolutely, yeah. So it's a house that, is, where is it being used in the world, or where can it perform in the world and make sense in the world? Everywhere and anywhere. And that's ultimately why they call it the international standard instead of the German standard.
That's cool. I like that. All right, last question. What can homeowners do to start incorporating passive house principles into their own homes, even if they can't afford to build a full-scale passive house from scratch?
We got this question asked lots last night.
Yes,
at the community event in Perth. So, an older home that people ultimately, elderly population as well, can't afford to build new. So retrofitting existing houses, something that is being thought of by ultimately most people, arguably anyone in Perth, in this town. And so retrofit is, they do say sometimes the greenest home is the home that is still standing, the home that's existing. And if the budget isn't there to rebuild, to recycle the materials and rebuild, still can be made energy efficient. Changing the windows and the doors, changing anything that is experiencing a high degree of air leakage, the building components would be number one. So windows and doors, due to the standard non-thermal bridge-free design that window ultimately has, and probably air leakage around the whole perimeter, would be step one for a limited budget. And then second part of the equation would be bringing in an aero barrier service to airtight the building and vapor tight the building through any exposed minor air gaps on the inside. So aero barrier service ultimately meaning the company Aero Barrier that comes in, they pressurize the house with a blower door, they release an air activated formula that ultimately goes to plug any minor gaps. And they can usually get the air tightness from most older homes, let's say, that are experiencing somewhere between 5 and 10 air changes per hour, down to, they can usually cut the air leakage in about half of any house they go into. So cut for existing homes, it might be difficult to insulate. So to upgrade insulation for the wall system, for example, would entail removing either the interior finish or the exterior finish. So this is where the major additional costs come into play. So, not having to worry about those items if they don't need to be done and if budget isn't available. Making the home airtight with respect to improving the air tightness 50% will likely reduce the utility cost about 35% just with the air tightness service alone. Upgrading the insulation to the attic, anyone that has an attic hatch, we've been told by the energy auditors that the attic hatch can sometimes be responsible for 25% of the air leakage in the building.
So where does heat go? It goes up.
Heat goes up, exactly.
Right? It's going straight to that hatch through that door.
And it gets sucked out like a vacuum if it's not sealed right.
That makes a lot of sense. All right. Well, thanks for listening, everybody, to this first episode of the Passive House Show. We hope you've learned something new about this exciting approach to sustainable home building, and we look forward to exploring more topics related to Passive House in the future episodes. If you like what you heard, please leave a comment, ask questions. We're going to be doing this. We're going to be releasing a couple of these a month, I'd say, for the foreseeable future. I've been Mick.
And Paul, and it's great having everyone on board.
Till next time. Bye.
Cheers.